the reading over the weekend. Remember, I gave you a homework and say you need to read this about the aisles ice cream store, the analogy that we talk about the output gap and the, potential GDP. So now chapter 11 is about Keynesian fiscal policy. So let's go over this very quickly. Because Keynesian is a descriptive word to describe this economy, very famous, called Keynes. John Maynard Keynes, and he became, popular right after the Great Depression. Wrote a book called General Theory. And today, that's right after Depression, the Great Depression, that is. So today, his fiscal and monetary policy is taught in every principles of macroeconomics class. So I have told you before, if you have not learned anything about Keynesian policy, it's like you have never taken any macroeconomic courses. You got cheated. That's how important it is. Okay, now remember that the other day I kept saying there were two things that were very important assumptions about Keynesian's fiscal policy. In fact, any of Keynesian's policy. What were they?
Short term and price is fixed.
Okay, very good. Short term, and what's the other one, Robert? Price is fixed?
Price is fixed.
Okay, very good. Now we're going to ask you that definitely on the test. I use the term definitely, right? So that means it's 10 out of 10. You get that question, but you may not recognize it. Why? Because you use so many terms to describe that price is fixed. We say, price is predetermined. Price is preset. You have to recognize it. You have to look at it and say, oh yeah, I got it, and you meet the demand as it comes. Remember the Owl's ice cream store example I said, okay, so this is hot summer day and 99 degree outside, so everybody's trying to cram in your ice cream store, and you look out the window, you say, oh wow, 200 people. Well, at first it's 20, and then the next time you look, it's like 200, so at that point, you have tendency to rush out and change the menu on the whatever price board or whatever you call it, from $1 per scoop to $2 per scoop. But you can't do that because the mob would get mad. So you can't do that in the short term. You can only meet the demand as it comes, so hire more workers. Get your cousin, get your buddies to come over, work overtime, and that sort of thing, until you have served every single customer. Okay. So, this Keynesian fiscal policy is very much hinged on that potential GDP we talk about, the two gaps, recessionary gap and the expansionary gap. Now, if you have missed that last class, it is absolutely very, very important that you read it. Because this chapter, that last chapter is the fundamentals or foundation for this chapter. This chapter is extremely applied. Guess what? You have a homework assignment that's due coming up. It's going to be due next Monday. Next Monday is also the day that we have tests on 2 chapters. You remember that? 10 and 11, yeah. So now, let me say this to you. Oh, can I do it? Yeah, actually, after today's class, you could do that piece of assignment. So if you want to show it to me on Wednesday, I will take a look and give you some direction. Now, this assignment, everybody, look at me very carefully. This piece of assignment is very extremely, looking at everybody's eye. Make sure you listen to me. Very extremely important that you do this piece of homework assignment on your own. Let me help you. So this is the one that I slow down a little bit. We have hands-on, in class, and make sure you can do this algebra. And we have a lot of class participation. Get students out and draw the graph and do that sort of thing. All this help. Because if you do not turn in this piece of assignment, you won't be able to do the next set. So it is that important. And it is very elaborate, but it cannot, you can do it. Yeah, I have since then, allowed me to help them or the TA to help them. And when I'm doing it in the class, do it with me, that really will help. Take notes, yeah. Okay, so let's go back to our famous diagram, which is this one. If you've seen it for the first time, please go ahead and draw. This is your potential GDP. So if you're to the left of potential GDP, we call this RG. Stands for recessionary gap, right here. So if you're to the right of potential GDP, we call this expansionary gap. And that's when you have excess demand. We got that $10,000 cash that we ready to spend, and there's a tendency for inflation to go up because there's excess demand. Everybody's rich, so the economy, inflation goes up because they feel like they have to raise the price instead of giving you great discount. Okay. So recessionary gap is being created because it's not enough spending. So come on, gotta spend more. And spending more means basically increase government expenditure. Well, I don't want to get into that yet because I'll introduce that coming up. Okay, government policy could be used to restore full employment. Now remember that everything that we do from now onward, that's it, is how do we eliminate the output gap using government policy? If you're in recessionary gap, how do we zip back here? And if you're in expansionary gap, how do we slow down or break the term that I used the other day so you can come back to this so-called potential GDP? So this is like heaven. There's your goal, Okay, and that's it. So without that, sometimes students say, oh yeah, y is equals to y star. Be careful now. If you say y is equal to y star, I told Nathan the other day, what will we do? We pack up your backpack and walk out, exit. Class ended. A month ahead because you have solved the problem. You have eliminated the output gap before we even have any problem. So economy is full of problem, and that's why we're here today to try to use monetary or fiscal policy to try to correct it. So if you start out with your premises is like, oh yeah, we don't have problem, y is always equals to y star. That's it. Back up, go home, class end a month, 6 weeks earlier because we solved the problem. It is not so. We got a task to do. Okay, in the short run, firms do not respond to every change in the demand for their product by changing the prices, so we call it sticky price. We talked about it the other day. Instead, you will meet the demand as it comes. And I'm going to introduce the word menu cost. How many of you have dined out before, like places like Outback and Ruby Tuesday, where they give you a menu? Yeah. They don't tell you verbally, oh yeah, today we got this, da-da-da. No way. They give you a menu. Have you noticed that the menu is rather impressive, usually, expensive looking? Yep. And have you noticed too that as soon as you finish order, the waiter or waitresses come around, take your order, everything, and what did she or he do?
Take your menu.
Yeah, right away. You can't say things like, could we give it for souvenir? Could we give it a little bit longer? No. Why? Because it's very expensive. They don't want you to keep it for souvenir. And guess what? So, sometimes you realize that, certain things, they change the price a little bit. And they use a sticky note, right? To put it on, to adjust the price. And it's almost always that the price is up. Have you ever tried to do that? They put a sticky note there and you kind of like, what was the old price? It's almost always low. So yeah, price is going up. And why are they doing that? Why don't they just print the whole menu again? Because it's very expensive. So we use that term, menu cost, to means adjusting the price. The procedures of adjusting the price usually is costly. Well, it's just like if you hear about inflation is going to be, say, 20%, drastic example. Today you read in the Wall Street Journal, you say, oh yeah, tomorrow or by the end of the week, inflation's gonna go up by 20%. What would you do? I bet if you're running a mom and pop convenience store, you would go up and down the aisle quickly, adjust everything up. Can you do it by hand? Yeah, if you have a small store, you can get your buddies, your cousin to come by and help you do it. Item by item. Today, if you're running a Walmart, is that possible? Not as likely. So that's why you go digital, right? You can scan the item and then the price is adjusted up. But then at some point, you still have to go from item to item and price it up. Office Depot, I think they do that. You know, they open like in the area 1 p.m. The reason that they open at 1 p.m. is you have to get there about 9 o'clock in the morning. And you spend all morning doing that. Because Sunday is a day that they adjust the price. You got a new weekly ad out, same thing CVS. They adjusted the price, you know, item by item, but they do it first on the computer too. So what this is saying is that it is only worth it to change the price if the marginal benefit of doing so exceed the marginal cost of doing so. And watch this is probably one of the most important line here. In the long run, firms will change the prices. So in other words, after we study 2 Keynesian's model, chapter 11, chapter 12, when we move on to chapter 3, we say, 13, we said, eventually prices would have to go up. Well, the ice cream store example, you know, you get to be beyond the capacity, then there is a pressure for the price to go up, and you cannot say, we are always in the short run forever and ever. No, not so. But at some point you have to raise the price. We call that long run. So let's come back to our famous equation. And in this case, you could see that our famous equation, instead of saying GDP or income, is now PAE. What does PAE stand for? It stands for Planned Aggregate Expenditure. That's our good trend for today and this week and next week. Total planned spending on final goods and services, the definitions are the same. C stands for consumption, your durable goods, non-durable goods, services. I stands for investment, you got fixed investment, residential investment, and all that inventory. G stands for, anybody remember? Government expenditure, government purchases. What is NX?
Net export.
Net export, which is export minus import. Very good. So everything there is the same except we change the term PAE. I'm skipping that one. Okay, so let's look at this term PAE again. I think I need a better pen because you will be doing that big math problem coming up. Where's the, okay. So next I want to define what is the plan in action. Now, most of us have experienced that, like you plan to do something, you know, yeah, I plan to do this weekend, I plan to read out these chapters of all my classes, but did you actually end up reading these chapters? A lot of the time the answer is no. Some of you are very good, you're go-getters, you know, say, yeah, I did, you know. But a lot of the time there's a discrepancy between what is planned and what actually did happen, correct? So same thing, you know, I talk about this car inventories, in a car dealership. Remember I mentioned that? So let's define this quickly. I is equals to, please write this down. This is not quite in the group. Well, it is, but it's not jumping out. So your I here is your actual investment. So your actual investment consists of 2 parts. One that is planned investment, the other one is unplanned investment. So for example, if you have 1,000, this is 100 plus 900. So remember I talked about the inventory for cars the other day. So let's use that as an example. In real life, we know that actual expenditure a lot of time is not going to be equal to what you plan to spend, the planned aggregate expenditure. Now, aggregate means everything in the economy because we study macroeconomics here, not micro. So we say that if your inventories, let's just take costs, are larger than expected, then your actual investment will be greater than planned investment. So this will be, this is a case, yeah, 1,000 is greater than 9,000. And this 100 is your unplanned, because you didn't expect that to happen, that you will end up having 100 cars, in a lot at the end of the year, by year end. So, now what about if the other case? If inventories are smaller than expected, this is a case that we don't have as much inventories, which is nice. In fact, you're short. So you have to call up the Loringburg or Fayetteville, Maxton store and say, well, yeah, come on, send over 200 cars or 100 cars, we're short. So if that's the case, right, the example will be like this. I want to use negative 100 and this I want to use 900. So this is a case where you actually have a negative inventory. It's just an example I give because in this case you see that your I, this is your I, will be less than the I of P, which is what is planned. What is unplanned will be what's left in the inventory. So I think this two example basically is just to tell you that in real world, what you actually end up spending, it's not the same as what you plan to spend. Whereas Keynesian's model is very much centered on this PAE, what is planned. Remember that, that's a very important assumption other than prices are fixed, short term and all that. Okay, so because of that we redefine. We say, okay, so this I right here is a planned investment. So then we add these terms there. Instead of I, we say I is a P, because this is talking about planned aggregate expenditure on the left-hand side of the equation. So next, I want to introduce take-home, what you call take-home pay or disposable income. Did we talk about it earlier in the semester? I think we did. Anybody remember? Did I talk about disposable income? Not really? Is this the first time you hear it? What is disposable income?
Savings.
Not quite, but yeah, you save out of disposable income. This is income minus tax. What we call take-home pay. So you see, your consumption should depend on this disposable income. Why? Because what if that tax percentage is quite high? Well, yeah, what if you earn 1,000 and then your tax is like 600? Ooh, you only have 400 left to spend, let alone saving, right? So that's what take-home pay, well, that's kind of like nickname we use for what is disposable income. So now remember that on the chapter on GDP we talk about it, consumption is about 2/3 of total spending of your GDP. And remember that column that we show you. And then we say that important or most number one determinant of consumption is your disposable income, or Y minus T. So next I want to introduce consumption function. You see, we're getting ready to build a big model, so I'm giving you parts by parts now, so you could digest it. Okay, so first I introduce what is consumption function. Consumption function shows, okay, never mind, let's get to the next page. Excuse me, yeah. Questions? Consumption function is you should have this in your book, please refer to your book, the definition. It's a relationship between consumption spending and its determinant. I'll show you equation next, and then we'll come back to this. Because sometimes equation makes more sense than just try to remember what it means. So, for example, if you were to look at this, historically, this is a U.S. consumption pattern. Okay, on your y-axis, you have consumption. $2,005, and that means you use 2005 as the base year, because you have to remember account for inflation. And what's on the x-axis? Your x-axis is not your income, but it is your disposable income. Because disposable income is more valuable than just income. Because, hey, you do have to take into account you owe Uncle Sam this much before you could even talk about spending, how much left after tax, how much left for saving, things like that. Okay, here's the equation. This is the one that you need to take note. I'm going to erase all that because we're getting ready to build a big model, starting with bits and pieces. So this is one important piece here. This is your consumption function. I'm going to write it here. C is to C bar. This is capital C, okay? Make a distinction. And then this C here is what I call a little c, a small letter c. See how little it is? Okay? So this y minus t is your disposable income, what I just introduced a while ago. This little c has a name. It is known as MPC. Got nothing to do with your music. That this is your marginal propensity to consume. Is this here somewhere? Oh, you see it in the next slide there. So what it is saying, see, when you use the term function, right, it's a mathematical function. It tells you relationship between x and y. Okay, so your x here is your consumption function, your dependent variable. So everything on the right-hand side is your independent variables. These things on the right-hand side explain what's on the left-hand side. Okay, everybody okay with that? Now, C bar is what we call, we have a special name for it right there. I'll write it down in English for you, autonomous consumption. What does the word autonomous mean? Anybody? Autonomy, that's what it comes from. Autonomous means independent. You're by yourself, you're on your own. So what this is saying is that C bar is a constant term. So this is like your high school equation, right? You got A goes to A plus BX. Remember that? Right? So this is your X, this is your Y. Oops, make it harder. A is your intercept term, B is your, come on, slope. Slope of what? Changing Y divided by changing X. Okay, that's what it is. This is your high school math, actually. Remember that? So you have y goes to dA plus dx, and it's upward sloping, so therefore there is a plus there. Everybody okay with that? I'm just reviewing high school math, really, at this point. Okay, so let's come back to this. So this is known as a constant term. This is A in your high school math. Also up here will be our C bar. What does it mean? It represents the income, the non-income determinants of C. So there's such a thing called, so autonomous means independent from income. Because you see that second term there, which is all these whole things together. This is one term, this is second term, nested, okay? So this one is independent of income, but the second term has income in it. Okay, so what are some of the things that will affect your consumption? That's not part of income. So if you go out today, you strike a lottery, has that got to do with your income? No, that's it. That's what it is. C bar could be explained by wealth, suddenly, inheritance. Your uncle, excuse me, nobody, I hope. Your distant uncle died, and you got a call from his lawyer and say, oh yeah, you're the only inheritor. You're the only heir. through his estate now. So he just inherited, congratulations, $10 million. Accept it, please. Get it, receive it. Right, so that's, and suddenly your consumption goes up. The next day we see you, you're driving a Ferrari, you know, things like that. So consumers' optimism, has got something to do with the state of the economy. Remember after September 11th, what happened? I know a lot of people were mourning. A lot of people say, oh, I don't want to travel. What if the terrorist is lurking at the corner? I don't want to be driving. It's just too scary. Well, that's the consumer sentiment at that time. Nobody wanted to invest. Nobody wanted to do anything. Everybody was feeling depressed because you're crying with those people who died and their families. You know, you hurt with them. You feel for them. That's consumer optimism. Real interest rate. Okay. If your real interest rate goes up like from 1% to 10% overnight, what would you do? Slap down that $10,000? Tell the bank manager, I want to open a bank account right now. Because interest rate has gone up by 10%. Wow, that is a lot. So straight away, that would affect how much you consume. Less, actually, because you want to put the money in the bank. You want to save more. And it could go vice versa as well. Okay, let's get to the point. So this is our consumption function. And so that's our C on the left-hand side, capital C, and C bar is autonomous consumption because it is the part of consumption that's not affected by income, which we just gone over, 3 of them. Okay, now this little c, I'm formally introducing this little c. Now, very important guy. This is known as marginal propensity to consume. And this number is so important because I'll have you calculate that on your homework. It's the amount by which consumption rises when disposable income rises by $1, and it is a fraction between 0 to 1. So what is that? 0.5 means half, right? 0.6, 0.75, 0.8, 0.25, 0.3. So it is a fraction, or decimal, if you would. So what it is, say this is 0.8. So we give example coming up. So it means that if Y minus D, all your disposable income, think of it as together. Y minus D is together your so-called disposable income. So if your disposable income goes up by $1 and little c is 0.8, that means your consumption will go up by 80 cents. Or 0.8 of 80% of this $1 increase. So that's what it means. Okay, there it is, your high school math. Except we translate everything, apply that equation. So now your C bar becomes your intercept term. Everybody familiar with that term, intercept term on your y-axis? Your y-axis is your C, your consumption. Your x-axis is your disposable income, thank you, is Y minus D. Not Y only, not T only, but Y minus D together. And this is your so-called equation. So it is moving up, so that makes sense, meaning that if your disposable income goes up, yeah, your consumption patterns, how much you consume will go up as well. So next, this is somewhat important, this part here. What's the difference between PAE and Y? Y is chapter 4, your GDP, your income, your output, all that. PAE is what we just introduced. There's a slight difference here. What's the relationship between change in production, income, and PAE? Okay. Now we say that we know that C is a big part of PAE because just now we wrote that equation. So I'm going to rewrite it again. How big was it? Didn't we say like, what, 2/3, something like that? Okay, so we got PAE equals to C plus I, so P plus G plus N X. I'm going to erase this because most of you would have chance to write this down already. And we'll leave the high school math alone, because we might need it again. So, because C is a large part of PAE, specifically about 2/3 of it. And then we say C depends on output Y. Where do we get that from? We get that from this equation, which I'm gonna call this equation 2 now. This is your equation 1. Okay, so let's label it together because we're going to get ready to build this big mortar. Okay, so C depends on output Y because of that second term there, of the second equation, the second term of the second equation. That is this one here's Y minus T. C depends on income because income is part of the function or equation. And lastly, by induction, or deduction, excuse me, if C is a large part of PAE and C depends on output Y, so therefore by deduction PAE has to be depending on output Y. Okay, so I mean, just take my word for it. Well, you could deduce it, but that's not important. So we'll come to that definition coming up. Next, are you ready for algebra? Take out your calculator. Let's do it together slowly so you're not afraid. Okay, so what we're gonna do is we're going to solve something. Okay, we're gonna solve a system or equation. And this is basically a normal problem. So do it with me now. Ask any questions you have. We'll do it very slowly so you can do it. So you got two equation, PAE. You have to start off with that PAE equation, okay? And then you have that consumption function as your second equation. And so far, these are all variables. You don't see any numbers. And then next we say, let's substitute. Do it with me. Substitute into 1. So what that means is, let's get rid of high school math. What that means is rewrite equation 1 slowly. This time you substitute everything on the right hand side of the equation into that. So you have, okay? Everybody okay with that? That whole thing is your consumption. And don't forget, because a lot of students, as soon as they let the cat jump on their desk, you know, they get distracted, they come back, whoops, they forget the rest. Ooh, big mistake. Telling you, I'm pointing out all the pitfalls here. So you still have this, you have to write down. Okay, so that's kind of like your equation 3. So all that we do is we just, this whole thing is your C. Everybody see that? You substitute in. Okay, so far so good. Next we say, haha, good news. We got a whole bunch of variables that we're going to just throw them out to you so you could catch them and say, thank you very much, Dr. Gunn. So we call these variables exogenous. Exogenous variables are variables that are determined outside the system. We already know the number, we just give it to you, and then all you have to do is substitute and say thank you, of course. Thank you. So this C bar equals to 620. And I suggest you write them out slowly, one by one. Why is that? Because I can tell you a lot of times students cannot solve the problem because they are copying this thing down on your paper wrong. Very common. 620 becomes 6,200. Whoa. 250 becomes 2,500. What? It's called careless. Hello. So next what we do is we say, what is the value of PA? So this is what we do. Help me out here. So we're going to rewrite PAE, everybody. I'm giving you a model to do it. So when you come to me and say, I cannot do it, I say, yes, you can. I've shown you how to do it. So write PAE again. What's C bar? 620. What's little c? 0.8. Why we do not know. So we leave that one alone. What is T?
250.
250, very good. Don't forget this. What's I of P? 220, what's G? 300, and X is 20. Okay, next, this is the techniques to do it. techniques to do it. I call it, do the easy one first. The easy one are the guys that I'm going to check. This guy, this guy, this guy, this guy. Leave that one alone because most of you will make mistakes right there. So let's do the easy one that we could do now. Yeah, you can do it by hand. 620, 220. Use your calculator if you want. 300 plus 20 is 320. We could do that one. 0, 6. Right? Did everybody get that? Okay, very good. So next we're going to, now of course you could use calculator here also, okay? So I'm just giving you the techniques like single out this easy one. So then we have 1160. Next we must conquer this one. This is where a lot of students make some mistakes. So copy it out. You have to expand out this term. Everybody understands? So this becomes 0.8y minus 0.8 times 250. Use a calculator. Tell me what is that? 80% of 200 is, 80% of 250 is 200. So then you have 1160 minus 200. What you got?
960.
Very good. 960 plus 0.8y. Whoa, done. That's not so bad, right? The bad thing is about it, you have to be very careful when you translate the number into your paper. And you have to remember not to drop off these guys. Okay, and you have to remember to do that term last. Expand it out slowly. This is where by far the most students make mistakes right there. So we got to this term here, and we're going to give these people a name. Because in your homework problem, we ask you. So there it is. If you see this now, it's not so bad. If I show you first, you faint and walk out. All right? 960 plus 0.8y. See, we could do it. Yeah, we done it. Okay, so what does it mean? So I think I explained that, but let's get to that last part here. Now this is essentially what your homework problem is like. When you get to this point, right, you got a lot of points already. So this is like, oh yeah. What's the next step? The next step is we tell you to identify where is autonomous expenditure, which is at 960. And the other term is called induced expenditure. This is also in your homework problem, we ask you that. Now, I want you to pay attention, your induced expenditure is not 0.8, it's not y, but is 0.8y together. So some student, they didn't want to have any misunderstanding, they write it out. It's 0.8y because I know the answer together. Not 0.8 alone, not y alone, but 0.8y. Because why? It is affected by income. It's part of the income. But whereas you look at this guy here, this is a pure guy, right? By itself. Autonomous expenditure. The part of the expenditure that's not depending on income by itself. That's it. You got a lot of points already up to there. Okay, so what's next? That's what it says here. Next, I want to introduce short run equilibrium output. We have not solved the equation yet. Have you noticed that? Okay, very good. I'm glad you noticed that. Let's take away this smiling face. Let's look at this definition. This is probably the most important definition for this chapter. It should be about 20 stars here. I ran out of space, but I ran out of typing, so I just put 5. But short run equilibrium output says that producers can meet demand and preset price in the short run, and it means that Y equals to PAE. So I'm going to solve it for you now using this. Okay, so this is where some of your math skill comes in. So I'm going to say apply Y equals to PAE, which is what we call short run equilibrium. Because in Keynesian model, we assume that short run equilibrium means your Y is exactly equal to your planned aggregate expenditure. So now you're gonna apply this. Well, I don't have to write short run equal. Apply y equals to PAE into, let's call this equation 3. Okay, apply y equals to PAE into. So what's what I'm doing? So next I'm substituting two things in like that. Whoa! You only have one unknown. We got rid of that PAE. Goodbye. Everybody see what I'm doing? So this substituting in like that. So this becomes easy now. Here's a challenge. How do you do this? Does everybody know how to do this?
Divide by one.
Okay, so this is what I do. I say y minus 0.8y equals to 960. I bring it to the other side. So this does everybody know y equals to 1y? Hello? Everybody knows that? I know a lot of students didn't know. So you could write it out like that if you want 1 minus 0.8. If you have $1, I ask you to I borrow 80 cents from you. How much do you have?
20 cents.
20 cents. Yes, very good. So this is your 0.2y equals to 960. And what do you do next?
Divide by 2. 1, 2.
Like that, right? Tell me the answer. Use your calculator. Divide by 0.2, yeah.
Is it 4,800?
Yeah. Okay, so finally you got y equals to 4,800. So is everybody okay here? So, does everybody understand what I'm doing? So what I'm doing, if you like, you could do like that. How about like that? That's the same thing, right? So y minus, so then you have basically, you have to put negative here. So negative 8y. So what I do is if I bring that to the left hand side, this becomes, because it was positive, when you bring it over, it becomes negative. That's how it is. So this one you cross out, and then this becomes y minus 0.8y. So then I collect the term together, so that's how I got it. So we solve that to be 4,800, and then we do a diagram. This is also in your book. Now in your book, there are two methods to do. They ask you to do it by process of elimination, which I find that to be more difficult. I find it easier to solve by equation. So we could go over that next time and see which one is easier for you. Well, hang on. Is that time already? Oh, you still got 1 minute, yeah. So now, this is your Keynesian cross diagram. In your homework problem, you're required to draw that diagram. So let's do it with me very quickly. So your y-axis will be PAE. Your so-called horizontal axis will be your y. Then you draw a line up. We call this line y equals to PAE. Well, let's call it income line. And then I draw another line like that. This is your PAE equals to, right here, 960 plus 0.84. This number here is your intersection, which is 960. 15 degrees. This is known as Keynesian cross diagram, and this diagram is worth one very solid point. You have to show this diagram in your homework assignment. Okay, I would highly encourage you, when you go home tonight, review this chapter, because next class, please do not miss it. It's probably the most important class in the whole semester. You've got to be able to understand what we're doing. Okay? All right, so I'll see you on Wednesday. If you want to drop the class for any reason, please talk to me. Instead of just drop it, because I like to sort of know why.